Bismillahirrahmanirrahim. For today, we are going to speak about the differential equation or differential equation of first order and first degree. Start with the definition of what we mean by differential equation. Differential equation is just an equation containing the derivative or the function and its derivative in the sum of the term of the equation. We can say it is equation contain the derivative as a term of the equation. And more general, we say that the first degree equation or a first order differential equation has the following form. Dy by dx, the form for the first order differential equation plus b of x y equal to q of x. This is the general form for the first order differential equation. When we say first order differential equation, it means this one. It is the first derivative of the function. If we have the second derivative, we will say second order differential equation. But if the equation only contains the first derivative, we say it is the first order differential equation. So dy by dx plus v of x multiplied by y equal to q of x. This is the general form for the first order differential equation. We are going to solve this differential equation, and to solve the differential equation means to find we need to find y. We need to find the value of the function or the function y. This is the meaning of solving differential equation. I need to find the function y equal or f of x equal to. Since we are using dy by dx, it means that we need to find the function y. And to solve first order differential equation, we have two methods. First one we call the separation of variables method, and the second one will be the integrating factor. For today, we are going to speak about method of separation of variables. Of variables. The differential equation h of y multiplied by dy dx equal to g of x. This equation can be written or say this equation therefore h of y multiplied by dy equal to g of x multiplied by dx. If we can write the equation in this form, or any equation can be written in this form, is called that is separable equation. We can separate the variable y from the variable x, the dependent and independent variables. Hy dy in one side equal to g of x multiplied by dx in the other side. This technique is called the separation of variables. We separated the variables x from y. And to find the solution, we will integrate the left-hand side and right-hand side. To explain this idea in more detail, let's take some examples. Solve the differential equation. By separation of variables. Let's take number 1 plus x to the power 4 dy by dx equal to x to the power 3 divided by 1. We need to solve this differential equation. Since we have two terms that we can separate x from y, let's start with that step. So the first step, we will separate the variables x and y. Separate the variables. All what we need to write the x variable in one side and the y variable in the other side. So I'm going to multiply this equation by dx first. If we multiply it by dx, the whole equation, if we multiply it by dx, I will have 1 plus x to the power 4 dy equal to x to the power 3 divided by y dx. We multiply this by dx and by dx here. This will cancel this one. So I'll have 1 plus x to the power 4 dy equal to x to the power 3y dx. Next step, I'm going to multiply it by y. If we multiply now by y, this means multiply not x. I will have y multiplied by 1 plus x to the power 4 dy equal to x to the power 3 dx. Next step, I'm going to divide by this one, 1 plus x to the power 4 there, and 1 plus x to the power 4 to the in the right hand side. So I will have y dy equal to x to the power 3 divided by 1 plus x to the power 4. Now in this step, you can see it is very clear that in the left hand side there is no x, and right hand side there is no y. So we separated the variables x from y or y from x. So we are done from the first step. Step number 2, integrate. I'm going to integrate the equation. So I will have integration of y dy equal integration of x to the power 3 divided by 1 plus x to the power 4 dx. The integration of y equal to 1/2 y squared equal Integration of x to the power 3 divided by x to the power 4. This is we can use integration by substitution. Let u equal to 1 plus x to the power 4. Then du equal to 4x to the power 3 dx, or dx can be written as du divided by 4x to the power 3. The final answer will be 1 over 4 ln 1 plus x to the power 4. Use just integration by substitution, I will have this. It is 1 over 4 ln of 1 plus x to the power 4. And since this is indefinite integral, we must have a constant c. So this is the solution for the differential equation. It is 1/2 y to the power 2 equal to 1 over 4 ln 1 plus x to the power 4 plus the constant c. Sometimes it is not easy to write the function y as a variable of x. I will keep it as it is. We can say that y equal to square root of 1 over 2 ln of 1 plus x to the power 4 plus the constant c. But I will leave it in this form now. So the solution for this differential equation is 1/2 y to the power 2 equal to 1 over 4 ln of 1 plus x to the power 4 plus the constant c. As I said, I have to add c because what I have is indefinite integral. And no need to find the constant c for this equation because we don't have initial conditions. So I will leave it as it is like this. Let's take another example. Number 2. Side square root of x, or 1 plus x to the power 2 divided by 1 plus y dy by dx equal to minus x. Differential equation. And we need to do it by separation of variable. So first step, I'm going to multiply by dx. So first step number 1, separate the variables. I will have square root of 1 plus x squared 1 plus y dy equal to minus x dx. If we multiply by dx, I will have minus x dx in the right hand side. Now I need to divide by square root 1 plus x to the power 2 because I have x in this one. So I will have 1 over 1 plus y dy equal to minus x divided by square root of 1 plus x squared dx. Well, what we did, we divided by 1 plus square root of x. This one will cancel this one. I will have 1 over 1 plus y in the left hand side and minus x divided by 1 plus x squared in the right hand side. Now second step, we will integrate now. Step number 2, since we finished from the separation of variables, integrate. So the integration of 1 over 1 plus y dy equal to integration of minus x divided by square root of 1 plus x squared dx. Left hand side will give me len 1 plus y, or absolute value of 1 plus y, just assuming that y is positive. So it is len of 1 plus y. Or I can just make it easy. I will use the absolute value. Len of absolute value of 1 plus y equal to right hand side minus x divided by square root of 1 plus x squared. This can be done using the integration by substitution. But this is very clear. It is 1/2 square root of, oh, not 1/2 only, will be minus 1 plus x to the power 2. The integration of minus x divided by 1 plus x squared equal to minus square root of 1 plus x to the power 2. This can be done by substitution. And since it is indefinite, we have to add the constant c. Okay, this is integration by substitution. So it is len absolute value of 1 plus y equal to minus square root of 1 plus x squared plus the constant c. Number 3. We take some trigonometric function. Cosine of x multiplied by dy dx equal to 1 plus y to the power 2 multiplied by e to the power secant x multiplied by tangent of x. Let's solve this differential equation. Again, all what I need to separate the variables first. Let's separate the variables. So I will have cosine of x dy equal to 1 plus y to the power 2 multiplied by e to the power secant of x multiplied by tangent dx. We just multiply the equation by dx, so we move it to the right hand side. It is tangent x dx. Now I have cosine. There I'm going to divide by cosine x here and there. So on the left hand side, I will have dy equal to 1 plus y to the power 2 multiplied by e to the power secant x tangent of x. And we divide by cosine x, which is 1 over cosine x. That will be secant of x. This term, 1 plus y to the power 2, we have to divide by this bracket. Left hand side and right hand side. So I will have 1 over 1 plus y to the power 2 dy equal to e to the power secant x multiplied by tangent x, 1 over cosine is secant x dx. Now we separated the variables x from y. We are done from the separation of variables. So I need to integrate. To integrate this one, I will have 1 over 1 plus y square dy equal to the integration of e to power secant of x multiplied by tangent x secant x dx. Now, the integration of 1 over 1 plus y square will give me tan inverse. The tan inverse of y. The integration of 1 over 1 plus y square equal to tan inverse of y. For the right-hand side, e to power secant of x multiplied by tangent secant. We know this one. Tangent and secant is the derivative of secant of x. This is the derivative. Means this can be done by integration by substitution, and I will have e to power secant of x. We know the integration of e to power secant of x equal to e to power secant multiplied by the derivative of the power, which is tangent multiplied by secant. And since this is indefinite integral, we will have constant c. So we can say in general y equal to tangent of e to power secant of x plus the constant c. And that will be the solution of this differential equation. Y equal tangent of e to power secant of x plus the constant c. So this is how to find the solution of the differential equation using the separation of variables. We have two steps. Step number 1, we need to separate the variables x from y, keep y in one side and x in the other side, then integrate and find the value of the integration. And that will be the solution of the differential equation.